We have to continue with experimental assessment. So next week, okay, remember, week 9, okay, 1 until 10, lucky number 1 until 10 have to attend the class at around before 2 o'clock. Okay, you can come 1:50 or 1:45, stand by at CL. And then second group have to come before 3 o'clock. Okay, so you are going to carry out experiment for reaction of aliphatic and aromatic hydrocarbon. So these are the skills that we are going to test you. First, make sure you wear proper attire, lab coat, okay, and fully covered shoes. Use protective eyewear, safety goggle, okay. Then you have to rinse the test tube or apparatus with distilled water before use. Okay, and then you have to label, proper labeling paper, okay, for the test tube A, B, C, D, E, F, G, H, I. Okay, and then for the test tube that need to cover with black sugar paper, right? Some of the sugar paper already labeled, so you just try to match, okay, the sugar paper that match with your test tube. Okay, this can save your time. Next, use dropper to transfer solution into measuring cylinder. So the dropper and the measuring cylinder will be provided. Okay, so you just go to measure 1 ml of the solution and then transfer to the test tube. That is okay already. Make sure that the dropper are placed in the appropriate container. Okay, so originally the dropper is inside the measuring cylinder, then you just follow. If beside the reagent bottle, you just put. Where is the original place? You just put it back. Only clean dropper are used in tampering solution. Okay, normally, right, okay, one dropper is specific for one solution. You just continue, okay, don't mix up. And then stopper the reagent bottle properly after use. And then the test tube are placed in appropriate container or rack. Don't hold your test tube by your bare hand. Must place the test tube in test tube rack. Okay, now for the part 1, chemical test 1. The test tube placed in the dark must be wrapped properly and placed in appropriate place. I think most of you already know where is the appropriate place, right? To prevent penetration of light. Second, student measure only approximate value. As I mentioned before, this is qualitative experiment, not quantitative. Okay, not necessary as approximately 1 ml of solution. So roughly near to that, or if you 0.9 or 1.1 is acceptable. Okay, so Madam will set time for you all if you don't overtake other people's time. Okay, step 3, the reagent bromine in dichloromethane is added only after the test tube is wrapped. Okay, then the test tube that need ultraviolet light must place at appropriate place that allow for the penetration of light. I think most of you know, right? You have to put outside of the lab. And then 5, the test tube are allowed to stand for at least 15 minutes. Use proper device to estimate the time. You might use your handphone. Also, sorry, you cannot use your handphone because your handphone, right, must place in the A4 box before you enter the lab. So you have to use the stopwatch. Okay, chemical test 2. Student measure approximate volume of reactant and reagent. And then use stopper before shaking the solution. Okay, just shake it gently. Okay, and then safety value, wait behind the line while queuing before the fume cupboard, and only user hands are allowed to cross and enter the fume cupboard. Okay, meaning that also once you handle it by all of the test tube by yourself. Okay, no others will help you. Okay, cleaning. First, all dirty apparatus is washed with the tap water. Of course, you have to remember, right? Okay, after finish the experiment, all the solution, right, must discard the organic waste in the organic waste bottle. Then only clean with the tap water, return the apparatus or glassware in the respective rack, and then laboratory table is clean, wiped, and arranged before leaving the laboratory. And detach the labeling paper on the test tube. Okay, after you detach the labeling paper, right, make sure the labeling paper throw into dustbin. Okay, take note. And then scientific attitude and noble value, honest in recording observation. Please bring a piece of paper to jot down your result. And then responsible about safety and tolerance of others. What means by safety and tolerance? So when you take the solution, right, make sure you within 1 or 2 minutes settle. Okay, don't consume other people's time. Please remember, there are 10 of you are going to carry out this experiment. If you take a lot of time to take the solution, right, you will affect others. Okay, please be considerate. Okay, that's all for this experimental assessment reaction of aliphatic and aromatic hydrocarbon briefing. Hai, mari kita semak lab report kawan anda untuk eksperimen for reaction of aliphatic and aromatic hydrocarbon. So title, yes, and then objective. So there are two objectives. The first one is to study the chemical properties of alkane, alkene, and arene. And the second objective is to differentiate an alkane from alkene and arene. So now the introduction part. So first is alkane. So the first point I said before, right? Okay, hydrocarbon are organic compounds that contain only carbon and hydrogen. And then alkane considered to be saturated, okay, hydrocarbon, meaning that single bond. Or another word is do not contain double or triple bond. So this is one of the example, methane, and the second example, ethane and cyclohexane, all considered as saturated hydrocarbon, alkane. So since they are saturated hydrocarbon, inert and known as paraffin, okay, do not undergo addition reaction, so they undergo free radical substitution. So this is the one of the equation showing that free radical substitution with UV. Okay, so react with bromine, right? Okay, must add inert solvent, CH2, Cl2 as well. Don't forget the inert solvent. And then the second one is alkane. So this is unsaturated hydrocarbon. What means by unsaturated hydrocarbon? With double bond or triple bond between two carbons. So this is one of the example. Carbon-carbon double bond is unsaturated hydrocarbon. Carbon-carbon double bond, cyclohexane, unsaturated hydrocarbon. So easily undergo addition reaction. So they can undergo hydrogenation and halogenation to form alkene and dihalide. So this one is, let me check. Yeah, okay, this is 1,2-dibromopropane. Okay, so propane is the alkene and then dihalide is the 1,2-bromo is the dihalide. Okay, so actually, right, if more accurate, we should emphasize this one is electrophilic addition. Electrophilic addition. Here, so be more specific. So the type of reaction for carbon-carbon double bond alkene is electrophilic addition. Okay, next, alkene also react with potassium permanganate solution in two different conditions. So this is what we have done last week. Okay, by adding potassium permanganate solution, which is in basic medium at room temperature, so it will form diol. So this is the diol, and there will brown precipitate form. So with MnO2, you can represent the precipitate with downwards arrow. Okay, upwards is represent gas, downwards is represent precipitate. So another case is hot acidified medium. Okay, this one is acidic potassium permanganate. So it will form carboxylic acid. Okay, you break the bond. So form double bond O over here, form double bond over here, there's hydrogen, that's why it need to continue oxidize become hydroxide. Same for here, continue hydroxide, oxidize become hydroxide. Okay, and then you check, actually this is not hydroxide, it's C double bond O OH, so is hydroxyl group, it's carboxyl group. Carboxyl group meaning that it will form carboxylic acid. Okay, next arene is aromatic hydrocarbon with stable molecular structure. So if you check, right, toluene, naphthalene, and antarenes, is it antarazine? So with multiple from the alternate double bond, single bond, double bond, single bond. So high degree of unsaturation and relative inert towards or addition reaction. So it can undergo addition, but at very high pressure and temperature. Normally, we focus on this electrophilic aromatic substitution, okay, with the presence of a Lewis acid as catalyst. So this is the Lewis acid catalyst. Okay, next is about procedure. I think should be no problem. Now we go for the result. So you have to alert under sunlight, right? All the solution, the reddish brown color of bromine solution decolorized. The reddish brown color of bromine decolorized, have to mention color. Okay, and then in the dark for cyclohexane, this one is negative result. And then for toluene also negative result. That's why you have to jot down the reddish brown color of bromine solution remain unchanged. Okay, then cyclohexane, no matter under sunlight or in the dark, all give the positive result. Okay, second part oxidation test with acidified CaMnO4. So the purple color of CaMnO4 solution remain unchanged for cyclohexane and toluene. Okay, only cyclohexane give the positive result. Okay, it will form the diol and brown precipitate. The brown precipitate is MnO2. So you have to mention the purple color of CaMnO4 solution decolorized and brown precipitate is formed. Okay, now discussion, we have to write down the equation and answer simple question. So cyclohexane, saturated hydrocarbon, undergo free radical substitution. So as I mentioned right first, okay, this is the positive result under UV in inert solvent. Okay, bromine inert solvent with UV. So meaning that what is the function of UV? To provide energy for the homolytic cleavage to happen to form the free radical actually. So this one you're going to learn the mechanism about this reaction later. So the product is 1-bromocyclohexene, very good. So not observable change for cyclohexene in the dark condition. Okay, next cyclohexene, unsaturated hydrocarbon. So electrophilic addition, okay, with and without sunlight. So it will give the same result no matter what condition. This one under UV, under sunlight. This one is in the dark condition. Also give 1,2-dibromocyclohexene. Very good. Okay, toluene. So toluene, okay, will form the benzyl bromide. Okay, have to take note, because it's undergo electrophilic aromatic substitution. Are you sure? Electrophilic aromatic substitution? Ding ding, something wrong over here. Actually, no. Okay, so suppose toluene undergo free radical substitution as well with bromine in CH2Cl2 in the presence of sunlight. Okay, so this benzyl bromide over here, okay, yes, correct, benzyl bromide, but the type of reaction is wrong. Is this one is free radical, because I say already, right, if there is a UV, confirm it's free radical substitution. Substitute the hydrogen over here, substitute by bromine. Okay, the electrophilic aromatic, right, is supposed to happen inside the ring. Okay, wait. If you check, right, if the reaction happen, okay, my color, wait. Sorry, okay. So if the reaction happen inside the ring, then only can consider as aromatic substitution. But now this one happened outside of the ring, so that's why this is free radical substitution. Okay. For the second condition, dark, no observable change. Okay, please take note, is free radical substitution. Okay, next Bayer test. Cyclohexane cannot be oxidized. Okay, so this is the equation. So no observable change. Okay, remember it's in basic solution. Okay, this one you can write in cold or room temperature acceptable. For our experiment, we just carry out in room temperature. That's why you just remain it at room temperature better. Cyclohexane, okay, it will form diol, and just now MnO2 is the brown precipitate. So it will form the 1,2-di diol cyclohexane. And then this one, no observable change. Okay, so that's why toluene cannot be oxidized. Okay. Now we continue. Yes. Okay, this student, Afiq, okay, title, objective, theory, yes, with theory, okay, all the theories. Okay, and then procedure. Okay, and then the result. Double check the reddish brown color of bromine. Yes, very good. Decolorized. Yes, very good. So for alkene, the reddish brown color of bromine remain unchanged. Yes. Okay, for cyclohexane positive. Yes, decolorized. Okay, so this one remain unchanged. So oxidation test with acidified CaMnO4, purple color of CaMnO4 remain unchanged. Yes, purple color decolorized and brown precipitate is formed. Yes. So remain unchanged. So very good. So this is a nice observation. Okay, so first one, okay, form 1 bromocyclohexane, no observable change. Okay, saturated. Okay, free radical substitution, presence of sunlight. Okay, this one, unsaturated electrophilic addition. Okay, and then with or without, yes, electrophilic addition. Please take note, electrophilic addition. So 1,2-dibromocyclohexane, 1,2-dibromocyclohexane. Toluene undergo electrophilic. Something wrong. Okay, again wrong. This one is free radical substitution. So second time already. So in the presence of sunlight. Okay, so benzyl bromide is formed. You have to take note. So this benzyl bromide is formed. Please write down your name. Okay, write down the name of the compound. And then this one, dark, no observable change. Okay, now second report already. So toluene undergo over here is free radical substitution because happen outside of the ring. Please take note, not inside. Okay, next. Okay, this one cannot be oxidized, so no observation change. Yes, can be oxidized from diol and O2. Okay, this one. Okay, I did mention, right? Okay, this condition is basic. That's why toluene. Okay, the structure of toluene is wrong. Please take note. The toluene is CH4. Don't simply write down the equation. So madam check again over here. Yes, this one. Okay, this one is toluene. Okay, this one correct. But how about this one? You miss CH3. Okay, please take note. While you write the equation, please be careful. Okay, double check. Okay, so this is UV. Cyclohexane. Okay, UV. No observable change. This one not UV, dear. This one is dark condition. So mistake. Okay, please be careful when you do the lab report. Okay, double check before you submit. See, this one is dark. Okay, in the dark condition. So dark condition in the dark condition. Okay, that's why no observable change. So if you check just now, right, this one is better. So this report, okay, you see dark. Okay, this one dark. Okay, but the problem is this report didn't continue for the precaution step, error, and conclusion. Okay, didn't answer the discussion question. So this is not a good report as well. Even though seems like all the answers are correct, but this report is not completed yet. Okay, be careful. Okay, you see this one correct. Okay, dark CH2Cl2. But how about this one? Okay, suppose one is UV, one is in the dark condition. So this one UV in a dark condition. Okay, and again this one UV, this one dark condition. But you see the toluene, yes, correct. But this one, forget about the CH3 pula. Okay, so remember this one is free radical substitution. Class, please take note. Okay, now we proceed. Okay, because this one is basic, right? So there is no observable change. Madam did correct it. Okay, so if this one is acidic, KMNO4, yes, it will form benzoic acid. But due to hydroxide, so it's no observable change. Okay, please do the full one, no observable change. Class, please take note. Okay, now we proceed for the next. After you write down the equation and the simple discussion for each of the equation, right, you have to answer few questions as well. So if you refer to my pre-lab video, right, okay, the first one, give the mechanism for the reaction of cyclohexane with bromine. Then you have to explain the function of sunlight in the bromine test, what is the purpose of bromine test, and then what is the color of KMNO4 solution, and state its function. And then the last one, why must certain test tubes be fully covered with black sugar paper? So let's go for the question number 1 first. Okay, initiation step, change propagation step, and change termination step. So you have to take note, the first step, change initiation step, there is one equation. Change propagation step, there are 2 equations. And then change termination step, there are 3 equations. So we have to show the arrow as well. Only this reaction we call as free radical substitution with half arrow. So first, okay, it will form 2 free radical. Okay, it will form 2 bromine free radical with the help of UV. So what is the function of UV? Later we are going to check. Okay, step 2, change propagation step. The step 1 is bond breaking, and then step 2, bond breaking and bond forming. First of all, the free radical bromine, okay, is going to attract the hydrogen. So here the bond between the C and H is breaking. So must point to C. So now it will form the alkyl free radical. Okay, and then the HBr will form a byproduct. So this free alkyl, this alkyl free radical will continue propagate, okay, the bromine as well. So here it will form the product of bromocyclohexane. At the same time, it will reform again the free radical of bromine. Okay, so over step 2, change propagation step, there are 3 half arrow. Okay, the last one, third step, change termination step. So it's the ending. Okay, means free radical meet with free radical and then form the product. So there are 3 possibilities. So cyclohexyl free radical meet with the bromine free radical, or the cyclohexyl free radical meet with the cyclohexyl free radical and then form 1,1 bicyclohexyl, or the bromine free radical meet with the bromine free radical and then form the bromine molecule. So this is the mechanism of free radical substitution. Remember, step 1, change initiation step. Step 2, change propagation step with 2 equations. And then step 3, change termination step with 3 equations. 1, 2, 3. Okay, I get it? Okay, explain the function of bromine test. So you must know the function of the sunlight or the UV is provide energy for homolytic cleavage of halogen. So in this case is of bromine to form the free radical bromine. Okay, in general is cleavage of halogen to form free radicals. Third, what is the purpose of bromine test? To differentiate saturated and unsaturated hydrocarbon. Saturated carbon is referred to alkane, alkana. Unsaturated hydrocarbon is referred to alkene. Okay, alkana. And then fourth, what is the color of KMnO4 solution? Okay, the color is purple color, and then the function is as the oxidizing agent. Question number 5, why must certain test tube be fully covered with black sugar paper? Because even a small exposure to light, right, will initiate the formation of free radical. Okay, so you must jot down these 5 discussion in your lab manual as well. Then followed by arrow. Okay, I did discuss with you all during the pre-lab review, and then the precaution step as well. Okay, conclusion. Cyclohexane and toluene undergo free radical substitution with bromine in the presence of sunlight. If in the dark, right, both of the solution no observable change, whereas cyclohexane is quite active, that's why it can react with bromine with or without sunlight. And then only cyclohexane can be oxidized by KMnO4 in basic medium. Okay, and then it will form diol and brown precipitate, means MnO2 precipitate. Okay, I hope you all can understand the post-lab video experiment 4. If any question, please don't hesitate to text madam or ask madam, consult with madam. Good luck for your practical test. That's all for this video. Thanks for watching. Please remember to subscribe, like and share. Bye!